So following on from the previous video, we got to this stage here. Our graph will look like this. It will head towards, as x tends to infinity, our graph will head towards 1 here, and that x tends towards negative infinity, our graph will also head towards 1. We now need to look at the critical points. So find out where the gradient of this graph here, find out where the gradient will be 0. So that means we have to look at the derivative of this. So now we need to differentiate this whole thing here. Okay, so starting with this, differentiate it. So it will give you so starting with this, blah blah blah, and then differentiate it, blah blah blah. It will take you to this stage here. Sorry, let's start again. Starting from here. Rewrite it as well. Differentiate this whichever way you want. Differentiate it, and then you would get to this stage here. Okay, differentiate it. You will get to this stage here, and then looking at this here. When you get to this stage here, looking at this here. At the moment, you've got one block multiplying with this block here, multiplying with this block here. Realize that this block, and then you've got this block here, times by itself. So you've got two identical blocks here. Okay. So now realize that here you've got exactly the same block here, exactly the same block here, and then you've got the two that's in common here, and the two that's in common here. So factor out the 2 and the x plus 3 here. Factor this block out and this block out. So take these two blocks out here, okay, and then take these two out as well. So pretty much we're factorizing it. So here you're left with this, and then you've still got one block here. That will then give you this. This x here is this. Okay. Well, whichever way you want, just and then tidy this up here. Okay, tidy that up, and then that will give you this. Okay, so now it's nice and neat now. So the first derivative of our function is given by this. Now find out when this thing equals 0. So this is our first derivative. Let f prime equal 0. So when you make this equal 0, well what will x be in order for this to be 0? Well, the thing is, when x is negative 3, then f prime will be 0. When x is 5 over 3, then f prime will be 0. Okay, so these are our two critical points here. So looking at the graph, so this is our graph so far. Remember we got to f prime here. F prime equals this. Find out when the gradient will be 0. The gradient will be 0 when x equals minus 3 and when x equals 5 over 3. So looking at our graph, the gradient will be 0 when at x equals minus 3 and x equals 5 over 3. So we need, so these two are our critical points. We now need to find out our critical values here. So we need to put this back into here. How? So to find out the critical value here, we need to put minus 3 into here and then into here. Well, the thing is, when you put minus 3 into here, so minus 3 plus 3, that would be 0. 0 squared would be 0, and then this thing here would be put minus 3 into here. Minus 3 squared, that would be 9, plus 5 equals 14. 0 divided by 14 equals 0. Okay, so the point, so now when you put this into here, our critical value will be 0 right here. Okay, and then do the same for this one here. Okay, so as I was saying, put minus 3. So this is our function here. Now put minus 3 into here. This is what we did earlier. Overall, it will be 0. Okay. Now do the same for 5 over 3. Put it into here, and then this whole thing here equals 2.8. Okay. So what that means is, So what that means is that our critical point here is at -3, but then our critical value here will be 0. Okay, looking at this critical point here, the critical value here will be 2.8. Remember, the 2.8 was this thing here. When you try and evaluate this, it comes to 2.8. Okay, and this 2.8 here is our critical value here. Okay, so that's our 2.8 here, right here. Okay, so now we now know our critical values here and here. Okay, so we know the gradient here will be 0. The gradient here will be 0. We just don't know if it's like that, or if it's like this, or if it's like this, or if it's like this. We just don't know yet. Okay, so now we need to look at the intervals. So we know the critical values. Critical point here is -3, and here 5/3. So now let's look at the intervals now. So looking at this here, between, well, when you look at f prime, looking at f prime here, looking at f prime, when you are in this region here, f prime will actually be less than 0. Okay, when you are in this region here, f prime will be greater than 0. When you are in this region here, f prime will be less than 0, and the way you can tell is by looking at f prime here, looking at the formula for f prime. Let's just okay, let's select. So when you're in this region here, let's just look at this region here. Let's just, for example, select an easy number. Let's say -10. Okay, so we are now in this region here. -10 is in this region. So let's put -10 into here. So when you put -10 plus 3, that will be a negative number. So this bubble here will be negative. So the point is that whenever you choose a number in this region here, this bubble here will always be negative. Okay, and then this region here, well, if you select a -10, let's say, for example, select an easy number, let's say -10. Put -10 into here. So that will, -10 times 3 would be -30, and then you've got a minus, so it's plus. So 5 plus 30. Well, this thing here will be a positive number. Okay, and this here is a positive number. So you've got a positive number times a negative number times a positive number. Overall, this thing here will be a negative number in this region here. Okay, and looking at this here, just looking at this bubble here only, okay, down here, if you draw that graph, x squared looks like this, x squared plus 5 will look like this. You see, this bubble here will always be a positive. And then when you square, now look at this, when you square the whole thing, when you square a positive number, this whole thing will always be positive. So from earlier, this was positive, this here will be negative, this here is positive, this whole thing here will always be positive. So this whole, now looking at this, the numerator will always be negative, the denominator will always be positive. So overall, the answer here will be negative. So in this region here, no matter what you select within this region, f prime will be less than 0. Okay, and then you can use the same argument for this region here. So first select something simple. Let's say 0. Put 0 into here. So this one here will be positive. Put 0 into here. This one here will be positive. The number 2 is a positive number. So you can see collectively, this is positive and this is positive. So this thing here will be positive. And use the same argument over here, and then it will get to a stage where f prime will be a negative. Okay. So now that we know that this here, f prime here is negative, so that means the graph, most of the time, it means that the graph is going downhill, downhill, downhill. And then over here, well, it's going. Hang on, let's look at this here. If you look at this, here the gradient here is negative. That means that means our original function will be going downhill, 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 downhill. Okay, and this one here, it must be going uphill after this point here. So well, if you have to satisfy this, downhill, 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 this one here, uphill, uphill, it can only mean this, downhill, 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 uphill, uphill, uphill. So it must be like this. It can't be doing this, downhill, 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 and then downhill, downhill. It just can't happen, because as soon as you cross over here, it must be going uphill. So it must be doing something like this. It must be doing something like this. Okay, and then the same argument here is going uphill, 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 and then downhill, downhill, downhill. So it must be doing that. It must be doing this. Okay, so looking at the interval, you know it's doing this and doing this. Okay, so we can guess that it will. But by the way, okay, so far, hang on. So far we've got this here. So far we know this is it's going to curve slightly up. It's going to curve slightly down. And another easy point here is the intercept. Is this intercept here? When you put 0 into here, it's quite easy to evaluate. When you put 0 into the original function, the overall thing here will be 9/5. So now that we know it's going to do something like this, and it's going to do something like this, and it has to cross the intercept here. So we can guess. Oh, by the way, it can't do this, by the way. It can't overshoot and then come back on itself. Otherwise, we would detect that there would be another. When we look at our derivative, there were only two derivatives. There were only, when we looked at our derivative, there were only two points when the derivative is 0, which is at this point and at this point here. It cannot do this, because here we would detect another point where the derivative is 0. So it can only join up smoothly like this. Okay, and now we know that now we know that this is heading towards 1 from the underside. Okay, so now we know it's going to do this from the underside. It's heading towards 1 from the underside, if that makes sense. Okay, hang on. So it's going to do something like this. Okay, and then up here it's going to do, hang on, we can get rid of this. We know this one here is going to head. We know it's going to head towards 1, but from the top. So it's going to do something like this, towards 1. It's heading towards 1, like that. Okay, and this one here, we guess that it has to go through the intercept. Okay, so we can guess it to look something like this. So something like this. Hang on. Something like well, you'll get the thing is there's an inflection point somewhere around here, because this one here is concaving up, and then later on you're concaving down. Okay, so you're concaving down. So there's a point of inflection somewhere in here, and then you need to look at this second derivative to find out the point of inflection. But we're not going to do that, because you need to work out a point of inflection for this particular function here. You need an extra piece of knowledge which I haven't shown you yet. So by right we should look at the second derivative as well. But just so that we can detect the inflection point. Because if you think about it, hang on. So you've got something like this here. You've got something like this here. Okay. By right, if you look at it, this here is concaving down. This is concaving. Sorry. We're going to leave the second derivative for the time being. Okay.